Hello everyone, today we are going to solve this problem. Determine the electrical field intensity at P at point which has the coordinates of minus 0.20 and minus 2.3 due to a point charge has the quantity or the charge of plus 5 nanocoulomb at the Q 0.2, 0.1 and minus 2.5 in air, and all dimensions are in meters. As we see, the wanted from this problem is determining the electrical field intensity, and in order to solve it we are going to use this form of Coulomb's law. Inside this equation we want four parameters. We want the charge, we want the quantity of the charge which is measured in Coulomb, we want the position vector of the point where we want to measure the electrical field intensity at, and the position vector for the charge, and the permittivity for the space that we are at. And in our problem, the space is the air. Okay, let's solve this problem. As we saw, we want to determine the position for the charge, which is r primed. R prime is the position of the charge, and as all dimensions are in meters, so we will consider the Cartesian coordinate system. Let's write this with the vector notation. It's 0.2 a sub x plus 0.1 a sub y minus 2.5 a sub x, a sub z. And the vector position for the point is r, which is minus 0.2 a sub x and 0 a sub y. There's no need to write it, and we have minus 2.3 a sub z. And let's find the difference between these two vectors, or the distance between the charge and the point, which is r minus r primed. No, this is the modulus. Okay, firstly let's find the difference, which is r minus r primed. We are going to only subtract x components, y components and z components accordingly. It's so simple operation. We will end up with minus a sub x times 0.4 minus a sub y 0.1 plus a sub z 0.2, and we want to find the modulus for this difference, and the modulus of it this vector is the displacement between the charge and the point, and this is the distance. And to find the modulus, we want to find the square root of the summation of the square of each component. We have 0.4 squared plus minus 0.1 squared plus 0.2 squared, and the answer is 0.458 meter. Now we have all parameters that we want to find the electrical field intensity. We are going only to substitute in this equation, but the problem that in the most of cases we prefer to write the electrical field intensity vector as a product between the unit vector a sub p and the magnitude of the electrical field intensity. So we want to write the electrical field intensity in this form: a sub p, which is the unit vector, times a sub p sub 0, which is the amplitude, or which is the magnitude or the amplitude of the electrical field intensity vector, and this unit vector equals to r minus r primed divided by the modulus of it, which is r minus r primed, and the magnitude of the electrical field intensity vector is q divided by 4 pi epsilon times r minus r primed squared. As we see, it's the same thing of it. both of them are the same, but the difference that in this case we have the vector as one entity, but in this case we have them as a product of two different entities. And now we are going only to substitute all parameters into this equation, and I'm going to do this in this paper. Okay, E sub p is equal to r minus r primed is this vector, and this is the modulus, which is Q is the quantity of the charge, and it's given in the equation it's 5 nanocoulomb, which is 5 times 10 to the power of minus 9 divided by 4 pi. Epsilon is the permittivity of the space where the electrical field where the electrical field is, and the space is the air, and the permittivity of the air is the same of the permittivity of the free space, which is 1 over 36 pi times 10 to the power of minus 9 farad. Okay, epsilon sub 0, which is 1 over 36 pi times 10 to the power of minus 9. And the square of the modulus 0.458 meter. And calculate these parameters, and we will end up with 214.5 times minus x 0.837 minus a sub y times 0.218 plus a sub z times 0.437, and the unit is volt per meter. This is the amplitude of the electrical field intensity vector, and this is the unit vector A sub p. See you soon in another lesson.